Welcome to today's class video. We are currently in a new topic which is motion as well as in momentum, motion and momentum. Okay, in this class video, we are going to dive into what is motion, the properties and the types of motion, the equations of motion, the parameters of motion, velocity diagram, how to calculate velocity diagram. Then before we move into momentum as a whole. Okay, now you might have come across the word motion before, either in physics, yes, especially physics. Yes, we often make use of this word in our daily activities and all. Okay, so now what is motion, if I may ask? Motion is the change of body position with time. That is the meaning of motion. When one changes his position, when one changes his body position with time, that is known as motion. When I put body here, I don't necessarily mean our human body. It can be the change of the thing you should take note of here is just position. Just position and time. That is what you need to take note of. Motion is just a change of position with time. When one changes its position with time, the thing is said to undergo what we call motion. Yes, motion is just a change of body position with time. Now we move further to the properties and the types of motion. Now there are different types of motion as well as categories of motion. Now, number one, we have translational or linear motion. Translational motion is also called linear motion. It's also called rectilinear motion as well. Rectilinear motion and linear motion, they are the same thing. So, one, translational or linear motion. It's so simple. This is just the motion along a straight line with constant direction, or motion of objects in one direction, e.g., motion of an object in a forward direction. Yes, translational motion is just the motion of an object in a straight line. Let's say this is a, okay, let me use a vehicle now. Let's say this is a car, for example. Okay, let's say this is a car. And let's say remember what I told you before. I said the thing we need to take note of is just position and time. Yeah. Okay, now let's say this car is in this position here, A, and it can't travel to another position which is B. Now, transitional motion or linear motion is just, let's say for example, now these 2 points are connected in just a straight line. Now when you can move from this position to this next position in this linear direction, this is known as what? This is known as translational motion. Translational motion just means the motion of a body in a straight line. Yes, the motion of a body in a straight line, or the motion of a body in one direction. That's known as what? Translational motion. So, example, motion of an object in a forward direction is an example of a translational motion. Then move to number two, the other types of motion. Now there are different types of motion. We have translational, we have rotational, we have oscillatory, then we also have random motion. Yes. Now rotational motion. Most people or most students, they confuse this with circular motion. Though rotational motion and circular motion, they are alike, but they are two different things actually. Rotational motion is the motion of rigid bodies about the center. Now please, there's a big difference between rotational motion and circular motion. They are two different things. Now the difference is that for rotational motion, the body, though both occur in circular direction, yes, Rotational motion and circular motion both occur in circular direction, but the major difference between rotational motion and circular motion is that in rotational motion the body just is moving about a fixed point, or is moving about a center. For example, the blade of his electric fan, the blade of an electric fan, is spinning, wheel of moving car. If you observe the blade of an electric fan, you find out that those three blades, they are moving about a fixed point, or they are moving about a center. Earth as well, earth spinning about its axis, the wheel of moving car. So don't confuse or don't mistake rotational motion for circular motion. Circular motion has a topic on its own. So there's a big difference between circular motion and rotational motion. Now move to the third one, oscillatory motion. Oscillatory motion is just the to and fro motion of a body, or upward and downward movement of a body. For example, now you are in a elevator or a lift. Now let's say you are in the elevator on a lift. The elevator usually move up or what, down. This is an oscillatory motion. Okay, let me just go to a more precise one. A simple pendulum swinging. A simple pendulum swinging to and fro. A simple pendulum swinging to and fro is also an example of oscillatory motion. There are many examples of oscillatory motion. Even simple harmonic motion is an example of an oscillatory motion. So oscillatory motion is just the to and fro or upward and downward movement of a body. So that is the meaning of oscillatory motion. Then move to what is called random motion. From the word random, you will know that random means irregular. So now, before then, I didn't give you guys the example. Now please take note of all these examples. They are exam based questions as well, especially in jamb and post UTME, even in WAEC. So remember, oscillatory motion is just the to and fro or upward and downward movement of a body. When a body moves moves upward and downward, that type of motion is known as oscillatory motion. This is an example. Wave motion. Wave motion is an example of an oscillatory motion. The motion of solid particles. Now remember, there are basically three states of matter: solid, liquid, and gas. But there are other states of matter, but for your level, there are basically three states of matter: solid, liquid, and gas. Now the molecules of matter that makes up the solid and that made up solid, these molecules, they move to and fro. They vibrate about a fixed point. So the thing you should also know that oscillatory motion is a to and fro motion of a body about a fixed point, upward and down movement of a body about a fixed point. Yes, that is known as what? Oscillatory motion. Wave motion is an example of oscillatory motion. Take note, oscillatory motion is also called vibratory motion. Yes, oscillatory motion is also called vibratory motion. Then also, this what you see here, SHM means simple harmonic motion. Simple harmonic motion, I said this earlier, is an example of an oscillatory motion. Then motion of a loaded test tube. Now motion of a loaded test tube placed in water. Let's say, for example, let me explain this. Now let this is a test tube. Okay, I'm coming. Let's say this is a bowl containing water. Okay, then this is a test tube. Don't mind my drawing. Now this is a test tube containing let's say some solid and all. Now you find out that this test tube will be moving downward and upward. To come down, to move up. That type of motion is an oscillatory motion, to and fro motion of a body, upward and downward movement of a body. So this type of motion is an example of what? An oscillatory or vibratory motion. Okay. Then okay, then move to rotational random motion. Random motion is just the irregular or the zigzag or disorderly motion of a body. When a body moves zigzagly or irregular, that type of motion is known as a random motion. Now please and please, the example I placed in all this type of motion, I didn't just take them from anywhere. I take them from past questions or past papers, from jamb past questions specifically, and they are usually questions that have been asked in recent years in jamb. Now Brownian motion is please take note of all this, please, very very important. Now Brownian motion is an example of a random motion. We all know that there are different types of motion. We all know that there is different type of random motion. For example, you know a butterfly. Now a butterfly moves zigzagly, but you don't expect jamb to ask you that one. They will say the motion of a butterfly. No, they will not ask you that one. But we all know that butterfly motion is an example of random motion. Now the one that we ask you will be Brownian motion, motion of molecules of gas. Yes, please and please, these are examples of random motion that you may likely see in your exam. And also under this oscillatory motion, wave motion, motion of a solid molecule, SHM, motion of a loaded test tube. All these are examples of oscillatory motion.